Okay, excuse me, you guys. Sorry, I don't mean to clear my throat as a start here. First thing you guys hear this morning. Anyway, good morning to you guys. We got at least 4 people online, and the rest of you guys here. In other words, if you ever given an expression of this form, A sine x plus B cosine x, okay? I'm going to prove to you this because sometimes, like in science, they may have a physical application where A sine x plus B cosine x, okay? You have to graph something like that. And you go, how do I graph a sum? You got a constant here, just so you guys can see this. Here's a constant A, and then here's a constant we call B. Okay? And of course you got, these are constants, A and B, and you got to graph this. You go, how in the world do I graph the sum of 2 functions? So this is actually just really the sum of 2 functions. So there is a way to do that. We got a way to do that, right? You guys see, you say, what are the 2 functions? Well, it's A sine x and then B cosine x. So there's a lot of physical applications that you study in science that's really the sum of 2 functions here. And the idea is to this. This is what we're going to do here. You're going to convert it. You're going to convert via the, sum and difference formulas. To a single sign. And that's the idea. You convert to the single sign here. So let me share with you guys how that's done, okay? I'm going to give you guys a fact, and I'm going to prove it to you guys. You say, what's the fact? If, get rid of the word if. This statement is equivalent to. How does your book want to write it? K sine x plus phi. Okay. Where K is the square root of A squared plus B squared. Okay, and what else? Cosine phi is defined to be A over K, and sine of phi is B over K. All right, so you're going to get these values here. This is A, this is B, and let's color K, I guess gold or something. See this K? This is what K is over here. Okay. So let me prove this to you guys. You go, you can prove it? Yeah, we can prove this. Here's a proof. We're going to start with A sine x plus B cosine x, right? You see this statement? Here's what we're going to let K equal the square root of A squared plus B squared. Okay? Then this equals K over K. Remember, K over K is going to be 1, okay? I'll put it this way, though. This will be A squared plus B squared divided by A squared plus B squared. This is the number 1. So 1 times anything is itself. So I can say, you know what that is? This is going to be A sine x plus B cosine x. Because remember, if we're going to let this portion be K, this is K over K, which is 1, just so you guys know. Okay? So in other words, we don't change the equality there at all. Now, I'm going to distribute here. I'm going to leave outside the numerator. And then that's going to distribute to the denominator. Right? Okay. Now, here's what I'm going to do. I'm going to change my color. I'm going to let you guys know. I want you guys to notate something here. I'm going to note. I'm going to create a triangle here. Here's your x-axis. Here's your y-axis, right? And call that angle phi. This is a right triangle. So I'm going to let this be my A value and this be my B value here. Okay, so we're saying orange and green, I guess. Okay. So here's my constant A, and here's my constant B, and here's the angle phi. Now, you guys know by Pythagorean theorem, isn't this going to be K? This is K, right? So, in terms of phi, do you guys want to tell me this? Let's say this. Do you guys realize something here? That what's the definition of cosine of phi? Do you guys know? Yeah, it's adjacent over what? Hypotenuse. That A squared plus B squared, because that's what K is, right? And then sine of phi is going to be opposite over what? The A squared plus B squared, or K. So we can write that as A over K, right? Or B over K. Okay, you guys okay with that? That's the angle phi. And then you have your colors, because this is from right triangles here. All right, and you go, okay, well, what does this mean? Well, if I say A square root, oh, you know what this one is? This one's right here. See this here? This is gold. That's cosine phi. And then what's this? So silver and gold. Isn't that sine phi? Right? You get sine phi. So far, here's what this equals. Okay, so far, this equals what? K cosine phi sine x plus sine phi cosine x. Okay, you guys okay with that? You said that AB sine x plus B cosine, this is what this equals? Yes, it does. Okay. Now, if I go back to the sheet here and I ask you guys, I'm losing colors. Pretty in pink. Do I recognize cosine phi sine plus sine cosine anywhere?
It's the sum formula of sine.
Right. Cosine, where is it? Cosine sine plus sine cosine. You know what that is? That's equal to, I think that's the first one. Is that right? Okay, you guys see, is that the first one on top? So what I'm saying is that this equals k sine x plus phi. And that's what I wanted to prove here. Okay, so let's go back and you say, what are we really saying here? Well, we're saying that this statement is valid. Easy breezy lemon what? Squeezy. Oh, come on. Okay, you guys okay with that? So then the question becomes now, what's going on here? They're going to say the following now as examples, okay? They're going to say what? How can we write, let's kind of keep it a little simple. Write sine x plus cosine x. How about if we just write the instructions up here? Write as a what? A single what? Sine. Constant 1, constant 1. Do you guys know what that means? Here's what this means. This is A, and this is B. Would you guys agree with that? Oops, wrong color. Is that A and B? Okay, you guys okay with that? Okay, what does it mean about K then? Right, K, isn't K defined to be what? 1 squared plus 1 squared because it's A squared plus B squared? So K would be 1 plus 1. Is that K is the square root of 2? Okay, so far so good. So you say, what do I need? You need the value for K. You got K. What else do you guys need? This is the Greek letter phi. Because if you're going to use this statement here, up here, okay, which you got as a single sign over here, you got the k value over here, right? Now you want to know what phi is. So what is phi? So how do you guys think you're going to get phi? Do you guys know how you're going to get phi? How do we get phi? It's very simple. Go back over here. Go back and use these formulas here, okay? What do I mean? That cosine phi, A is 1. What is K? Square root of 2. And then sine phi is what? A is what? Or B is also 1, square root of 2. Let me also make a big remark. Let's notice something here. Cosine of phi is positive. Sine of phi is what? Positive. What does that mean about phi? Phi is in quadrant 1. Is that right? Not only that, I think you guys should have this memorized. What is phi going to equal? Do you guys know? How do you find phi? Well, yes, you can. You could use that, but we'll get there. But you guys may already know what phi would be. What's phi? What's 1 over the square root of 2 for cosine and sine? Phi is 45 degrees. Is that right? So you don't always know. I'm going to just remark about this. It's not always, in some sense, that easy. Yes, you would have to use your calculator, but phi is pi over 4, ladies and gentlemen. Is that right? Just going to remark about that. So once you get k and phi, what do you say? Square root of 2 sine x plus what? Pi over 4. Easy breezy lemon squeezy. Easy breezy lemon squeezy. Oh my God, Mr. Judge, really? Yeah. Let's give you guys another example. They're going to give you now 3 sine x plus 4 what? Cosine x. We're going to have to write this as a single sign, one sign, just like we did before, right? So all I'm saying is you're just going to use this what? You're going to use this fact, this format I proved for you guys. Okay, you're going to use that. Now, how do you start? Define k. What's k? Okay, you say k now. Remember this? This is A, and then this is B. K is going to equal square root 3 squared plus 4 squared. Square root of 9 plus 16. What's 9 plus 16? So this will be what, 5, okay? K is 5. Okay, you guys okay with that? Easy breezy lemon squeezy? Okay, you got K. What do you guys need to get now? I'll write it down. What is phi now? Cosine phi. What's A? 3. 3. What's K? 5. And what else do we know? Sine phi is what? 4/5. Aren't they both positive? So phi is in quadrant 1. Is that right? All students take calculus? So then here's what we have to ask. Again, we're going to ask the same question, right? This is phi. Now, I'm going to introduce you to you guys. You may know this already. Oops, sorry. You may know this. I need to get phi. This means phi is the inverse cosine of 3/5. This also means phi is the inverse sine. So we're going to have to talk about inverse functions, right? Inverse are reverse functions. We have this inverse what? Functions. -1, -1. Inverse cosine. Second, you see this here? This is the inverse. You guys see? Oh, no, you don't see it. Let me go back. Okay, I'm going to share with you guys this here. Okay, let's find it out. Let's find out what this is. So we're going to say the following. Second, inverse cosine. Inverse cosine of what? 3/5. What do you guys get for phi? This is 35 or 53 what? Degrees. Sorry. Okay, so here's what I want to ask you guys. Since you know this is in quadrant 1, what's the deal? This is quadrant 1. That's the angle. I don't have to check sine because what's the deal? If they're both positive, they're in quadrant 1, and 53 degrees is in quadrant 1. So, ladies and gentlemen, final answer is going to be, okay, you say, what's K here? 5. 5 sine x plus 53 degrees. And there you go. Easy breezy lemon squeezy. Follow your format. And I want you guys to note something here. You said, what if they had given me 3 sine x? I'm going to share with you guys. 3 sine x minus 4 cosine x. Okay, this is a note. It's another example, but it's a note. Remember, this is still going to be what? A. And this is going to be B. K will be what? Square root of 3 squared plus -4 squared. Square root of 9 plus 16. That's still going to give you what? 5 for K. Is that true? So K here is what? 5. All right, you guys okay with that? That's K. So what do you have to answer again? What is what? Phi. So if you go back to these equations now, what changed? Do you guys know what changed here? Yeah, the sign changed. Is that right? For the B value is different. It's opposite. So I want you guys to consider this. This is going to be what? Negative. Is that right? Is that right? This means phi will be what? Inverse cosine of 3/5. We already seen that. Is that right? You said, I did that already. I used that inverse, and I got 53 degrees for phi. Okay? Didn't we get that over here when I used the calculator in the past? This is what I'm saying. We did this. But what do you guys know about phi? You see, this is not the phi. I'm going to write this down. This is not our what? Phi. Does anybody know why? I don't. Yes, let's find out where phi is. Where is phi at? Let's find the picture. You guys remember that? I spent all this time on this picture. Since I spent all this time on it, we might as well use it, right? So all students take calculus. We know cosine's positive, but sine is what? Sine is negative. Is that right? Sine's negative. And what do you know about cosine? Cosine's positive. So what quadrant what quadrant has that? Cosine's positive in quadrant what? 1 and quadrant 4. In quadrant 1, what do we know about sine? Sine is also positive, but in quadrant 4, sine's negative. Is that right? So what do you think this gave us? What do you think that 53 degrees refers to? Right, because you go, Mr. Judge, it gave me 53 degrees. This is a quadrant 1 answer. It's not a quadrant 4 answer. What it gave me is this thing. It gave me the what? The reference angle. It gave me the reference angle, ladies and gentlemen. So since it gave me the reference angle, what is phi really going to be? We can say it two ways. I can say, ladies and gentlemen, that phi is minus 53 degrees. Is that right? I can say it that way. Phi is what? Minus 53 degrees. What else can I say? That's right, 360 degrees minus 53 degrees. And what does that mean about our phi? 307 degrees, ladies and gentlemen. So I just want to kind of remark there, either phi would be good. Yay? Nay? You guys see what I'm saying? So I don't know. I'll pick 307 or minus 53. Okay, so here's what we get now. K is still 5, right? Final answer is 5 sine x minus what? 53 degrees. Here's K. Here's phi. Here's the answer. Easy breezy lemon squeezy. Let's try one more. I'm going to do another one. So a sine. Give you guys another example. Okay? What if they said to me, negative sine x plus 3 cosine x. Okay? This is my, what is this over here? Here's my A, and then what do I have over here? B. A, B. K, square root of what? A squared plus B squared. Here's A. Here's what? Here's B. Square root negative 1 squared plus 3 squared. Okay? Isn't that 1 plus 9? So what is K? Square root of 10. All right, you guys okay with that? No big deal. You got your K. That's the definition. But what do you got to use? Sorry. I'm choking. We got to use this. Got to use this. And do that. So what's A? Negative 1. What's B? 3. Cosine phi is negative 1 over the square root of 10. Sine phi is 3 over the square root of 10. Okay, cosine's negative. Sine's positive. Let's find what phi is. Okay, let's go to the calculator because we need phi. Is that true? So how do I get phi? Do you guys want to tell me? Use inverse cosine of negative 1 over the square root of 10. This will give you your phi now. Sorry, clear that out. Inverse cosine of negative 1 divided by second square root of what? 10 here. Bring that out there, parentheses. What does this give us? Let's go to the nearest degree, okay? What does that mean to the nearest degree? Is that 108 degrees? Okay, you guys okay with that? You guys see that there? You get to use the inverse cosine key. We're going to learn inverse cosine at the end of the chapter, but whatever. There's your phi. But the problem is all students take what? Calculus. So what do we know here? Right? Cosine is what? Negative. Sine is positive. So where is sine positive? Quadrant 1, quadrant 2. Okay? Sine is positive in those two quadrants. You guys okay with that? So does it make sense that phi is 108 degrees? Yes. What's the deal? Right? 90. This is going to be where phi is. Because that's 108. So that makes a lot of sense. Okay? So what's your final answer? Square root of 10 sine x plus 108. You did find the right phi. Doesn't always make sense, ladies and gentlemen. I just want to warn you guys. There you guys go. It's going to equal what? 108 degrees. Easy breezy lemon squeezy. Follow this what? Format. Should we try another one? Should we do another? Or let's do this here. Let's look at your textbook. Oh, I forgot to prove these cofunction identities. You guys can prove it. It's not, whatever. Let's share this with you guys. Just look at the graphing. Minus 3 sine plus 3 cosine, right? Minus 3 sine plus 3 cosine. Let's go to decimals. Or let's do the first one we did. They said, what is the graph of sine? We're going to graph this. Y equals what? Sine x plus what? Cosine x. Remember that first one we did, the first example, y is sine plus cosine? That's the curve. You go, boy, that looks like a sine or cosine curve. Is that right? But remember, what do we do in Desmos? Or what did we do earlier, that first example here? Okay, we'll go with the easiest one. It doesn't matter, but what do we find, right? Sine plus cosine, what did it become? It's right here. Okay? Square root of 2 sine x plus the pi over 4. The point I'm making is, can you guys graph that? The answer is yes, you can graph that. Is that right? What's the amplitude? Square root of 2. Do you guys remember that? What's the period? Blah, blah, blah. You guys remember that? Period is what? 2 pi over what is k? 1? 2 pi. What's the interval of one cycle? What's the phase shift? You guys remember that? Negative pi over 4. Is that right? So you guys can get the interval of one cycle. But if I look at Desmos, you say that's y equals square root of 2 sine, right? Sine of what? X plus, what is this? Pi divided by what? 4. So here's what I want to remark. Let me change the color. Let's change this color. Maybe green. I don't know. Are they on top of each other? Yeah. What does that mean? They're the same, aren't they? Anyway. So, I mean, if they ask you to graph, you say, oh, okay, I know how to graph. Right? So I'm looking at Desmos, not Desmos, I'm looking at this thing here. Let's do 41 to 44. 1 do what? 12. 41 to 44. 7.2. Assignment. Homework 3. Edit 7.2. Say 1 to 12 all. And then, what do we say? 40 what? 41 to what? 41 to 44, right? So what I'm saying to you guys, I already put online in Canvas your homework from the book. Homework 3. You guys want to kind of look at those questions or the things that we did. And I'm just going to be consistent. It's a little bit, let's bold this. All right. You guys see that there? So you guys can get started on some of these. Okay? It's the stuff we kind of went over. So anyway, you guys, take care and stay safe. And we'll see you guys when? On Monday, okay? Take it easy.